Hello, I'm Robbie Clark, welcome to my workshop. I'm just about to start another little project. A little while back I was given 3 of these quite large bolts. They're nominal 20mm and they're, this one's to 8.8. The one I'm actually using, this is type 10.9, so there's obviously sort of high tensile bolts. This one I've cut a section, you can see a section of the end, which includes all of the thread and part of the shaft of the bolt as well. I'm going to machine, I've got this part actually in the lathe already. I'm going to machine off all the thread down to about 12mm. I mean, so far it's machining very well. I'll just bring you in and show you this, and perhaps do a couple of passes on the material itself. And then with one, it was basically to see what the material would machine like actually, and it seems to be machining very well, so I'm hoping this will be perfect for the job. And I'm always looking out for any, if you like, scraps of material. I mentioned to my son that I was looking for various bits of metal. He got me another very large bolt a little while back, which I've made a couple of things from, and the other day he gave me these were just sort of found items. They were basically scrap, so even though they're scrap bits of metal and they can't be used as actual bolts anymore, for me they're like gold dust. Absolutely perfect for working here in the workshop, and they do seem to be machining okay. But let me bring the camera in and just show you. Okay, I've got the straight part of the bolt gripped into the chuck here. Before I did this, I pushed the bolt into the chuck as far as it would go, so that I could face off the end and put a centre drill into it, so I can grip the end of this with a revolving centre here. And now I've got it just gripped by, you should see, I don't know if you can see, I've actually, this is where it's sawn off here. So I'm gripping the end here, so I'm only exposing the thread part. I've turned the compound at an angle so that I can get the tool between the end of the material and the face here of the live centre, and I'm just going to very carefully machine the thread off and then machine it down to 12mm. Obviously the ideal thing would be to use the auto feed on this, but the auto feed is quite noisy. I'm actually waiting for a special oil to arrive to try lubricating the change gears at the end, because they are quite noisy. So what I'll do in this instance, while I'm trying to film it, is I'll run the carriage basically by hand. Well, to give you a bit of an idea, I tried a slightly heavier cut in this instance, and I am getting a fair way down on through the thread now. So I'll carry on with this and try and clean this up and start machining it down to the 6mm diameter that I want. Once I've done that, I'll actually talk about what I'm actually making in this project, which I hope you're going to find of some interest. Anyway, I'll bring you back later on for a bit more of this. It's a bit boring to watch me machining this, so I don't want to do too much more. I think this is my final cut now. Let's see if we get sort of near to the 12mm measurement. Okay, let's see how that measures up. So if I can get in around the camera. When I'm about, I'll get that in focus for you if I can. Some about 1/1000th, which is fine for this particular purpose. That's fine. And what I will do is measure this with a micrometer as well along the length, you know, to make sure I've got everything nice and parallel. But I'm sort of quite happy with that, and that it was just an old random bolt has actually machined up surprisingly well. Actually, I'm quite pleased with it. It's obviously quite tough because I did burn out one of the tips here, so I had to put another tip in. So I kept the damaged one to sort of use that just to machine a lot of the material away. And then for the final few cuts used a brand new tip, and that's come out quite nice. But certainly within 1/1000th, that's more than near enough to the measurement I need. But I'll bring you back for the next bit. This is now needs to be sort of turned round in the chuck to do the machining at this end, but then I'll explain exactly what I'm trying to do here. Well, this is where I am so far. I've machined this section down here to, well, the aim was 12 millimeters. It came out a little bit under that. It's 11.65 millimeters, which is okay. What I'm actually making is a dovetail cutter, and I want to make the dovetail cutter using little carbide tips. I bought this pack of get them in frame there. This little pack of carbide tips, which should do the job. So these are 60-degree inclusive angles here, which is going to be exactly what I need for the job itself. I have got a dovetail cutter already, quite a small one, which I bought many years ago when I was making a lot of tool holders for my Chinese mini lathe. I made, well, goodness, about 15 or 16 of those, so I made a huge number of cuts with it. But I noticed that there's a lot of people on YouTube channels that use carbide tipped ones, and also make them as well. One, for instance, is Randy Richards, who makes a couple of different sizes of dovetail cutters, which he sells on his channel. But I thought I'll have a go and see if I can make my own. The cutter it will just have one tip on one side, so that's going to be the most difficult part of the whole process, I guess, in setting this piece of material up properly in the milling machine to cut the pocket on the piece on the end here. This part will actually be machined down to, I think it's something about 19 millimeters, or 3/4 of an inch roughly. So what I'm doing next, before I break this setup down, what I want to do is machine, I suppose we call it an undercut in here, because I noticed the little high-speed steel dovetail cutter I've got's actually got quite a severe undercut in here. It's undercut and then sort of chamfered out on the side, so I'm going to attempt to do that. I'm going to see if I can actually start the cuts off at each end with a parting off tool, and then machine the centre part of it out. I'm only going to take it down to probably something, I guess about 10 millimeters would probably be enough, and I guess that's, you know, well, hopefully enough to give me some clearance basically. Once that's done, I probably will reduce the length of this shaft, so this shaft will obviously fit into a 12 millimeter collet, and obviously that will close down enough to lock this part in place, but I don't think I need it to be anything like as long as this. So probably reducing it down to sort of about here, I guess, but I think that probably would be about long enough, so I can just sort of part it off here, hopefully part it off here to give me a nice sort of clean end to it. Then I can turn the part round and cut the angle across here. I'm going to bring you back while I attempt to do this. I just tested it. It seems to be cutting okay. I've no idea what this steel actually is, because as I mentioned before, it's a section off a large bolt, but the the finish I got on here is very, very nice indeed, so I'm hoping that everything else will machine much the same way. I mean, let's see if I can basically make some sort of depth marks at each end here. I've marked sort of roughly where I want it to end up here. There's a little black mark on here, so I think is going to be enough length in that undercut. And I'm not going to take the undercut in too far. Obviously I don't want to weaken the material at all. Obviously I've slowed the lathe right down as well. I can move that along to sort of roughly line up. It's not got to be that precise, but line that up roughly with the little line I've put on here. Well, that's given me a start. I'll carry on with this and bring you back when I'm sort of near to the end of doing this. Obviously it'll take a little bit of time to machine that part out. I might just try moving the parting off blade along and then perhaps just finish it off with a regular cutting tool afterwards. But I'll bring you back. Well, hopefully that'll will be enough. I've taken that down. It's probably just a little bit below 10 millimeters, but I think that hopefully that undercut will be okay. Yeah, I think that'll be okay. And I've got sort of, you know, a bit of a sort of rounded, well, a chamfered edge on that side, which the tool itself has cut. So that's sort of basically it. I think the next stage probably will be parting this off to length, and then I can turn it round in the chuck and do the machining to this end then. Well, I've taken things a little bit further. I did most of this off camera. I've parted it off to length. The shank on here is about, I think it's 2 1/8 inch long, and I sort of measured that from the high-speed steel one I've got, so it's a similar length, perhaps a fraction longer. So as I say, I parted off, I've chamfered the edge, and I've put a centre drill hole in the end here as well. I did move the part back in the chuck a little bit. I don't think it gave it a better grip, but you know, perhaps that helped a little bit. So that basically, this end of it is completed. Now is all the fun of machining the other end, so I can reverse this in the chuck and machine the angle across here. It's going to be a 60-degree dovetail cutter, so I need a 30-degree angle across here. So I'm going to cut what I'll do is I'll cut the angle first, I think, into this shoulder, and then I'll machine the end off then to length. The rest of it I'm going to have to figure out. I've got to somehow find a way of mounting this in the milling machine so that I can machine out the other angle across here, including the pocket to take the little carbide cutter as well. So that's going to be a fun part of the project, if I can sort of figure all of that out. But I mean, so far it's come out quite nice, and I'm quite pleased with the finish, really, because the material I used, so I suppose what you call is a mystery material, but you know, I'm quite happy how it's turned out so far. So I'll obviously bring you back when I'm set up to machine this side of it. Obviously I've got to set up the compound on the lathe to cut that part as well. Well, I'm set up to cut the 30-degree angle across here now. Obviously I've reversed the part in the chuck. I've put some soda can material around here just to protect the surface a little bit in here as well. I've already faced the end off to make sure that's nice and square, and I've brought the outside diameter here down to 3/4 of an inch, 750 thousandths. I didn't bother to show that because it's quite just straightforward turning, and just broken the sharp edge here. The compound is set up at 30 degrees, and I just played around with everything on here just to make sure that I've got good clearance everywhere for the tool holder and cutting tool against the chuck, so there's going to be nothing clashing. I'm just going to take this very, very gently and bring the angle down. I'm going to, when I've cut into this a bit, I'm just going to check, because I don't think I may not need to bring the angle right into the thickness of this shaft, or it may need to stand off from that a bit. But I think the important thing is that when I cut the angle here, that I've got the right amount of depth here to take the little carbide tip. But obviously I'll check that out as I get a bit further on. I'll just make 1 or 2 cuts for you, and then I'll do the rest of it off camera and bring you back ready for the finish of it. Okay, I'll stop there and I'll bring you back near the end, because it's going to be rather boring watching me cutting all that away. But I'll bring you back when that's really down to the shape and at the right sort of depth. Well, I've completed the angle cut here, which I hope is going to be okay. I did in the end bring it down right into the corner here, and I think the depth will be enough, because when the tip's mounted in, I guess the tip needs to lay a little bit proud of the end here. Obviously this end part here is going to be machined back, and then the tip will overlap that slightly, so that it's proud of the bottom edge and also proud of the edge here, so that it's then only if you like, that part which will actually be the cutting angle. So I think that's how it will be set up. So I think the next job will just be to machine some of it, or this back, sort of fairly close to the finishing point here. Probably leave a slight parallel bit there, I don't know, but obviously there's got to be enough room when the pockets cut out from here to allow room for the little retaining screw to go in here. But obviously I'll have to sort that out a bit nearer the time. But anyway, that's that part, I guess, is done now. I did wonder whether I needed a bit more of an undercut here, but that obviously that could be machined into there later on if I find that little shoulder there's a problem. I don't know at this stage, but anyway, it's moved on quite nicely. So just sort of machining that part down. Obviously I won't bother to show that bit again. It's just sort of fairly standard turning, but I think the next time I bring you back is probably when I figure out how to set this up in the milling machine to cut the sort of angle across this way for the little pocket for the carbide tip to sit into. Anyway, I'll sort that out later on. Off camera, I've machined this back, this face here, so it's face back to basically the edge of the angle that I've machined in here. I've not taken it to a sharp point. I've just left a slight edge to it as well, and I've used a centre drill just to make a very, very tiny mark in the centre here, so that I can use this as a data point when I machine basically a lot of this section out here. So basically that's all the machine work finished really on the lathe. I'm just going to sort of break the edge here, and there's nothing really much to clean up. I've got a nice finish here, reasonable finish on the angle I've cut here. It's not brilliant, but I think it's sort of reasonably enough for the job in hand. So that basically finishes that part. Now I've got to somehow set this up in the milling machine so that I can actually machine that section out here to take the carbide tip, and it's got to be cut sort of across this way at a 30-degree angle. So that's I've come up with 2 or 3 ideas. I think 2 of them are just not going to work, basically because my milling machine isn't really big enough. It has a very, very small or narrow table, and there's not a great deal of travel but I'll try and show you what the problems are, and then hopefully show you the idea I've come up with to do this, which I hope is going to work. Anyway, I will leave it at that for the moment, and I'll bring you back when we're sort of ready to set things up on the milling machine. Okay, the next job I've got to do is to cut out a sort of a pocket on this side here, so a lot of this corner is going to be removed and machined out at a 30-degree angle across here. The problem I've got is that the limiting factor on my mini mill is the amount of travel that I've got in the Y direction. I've not looked at this very carefully before, but what I do is put a drill chuck in the milling machine, and then use a pointer to see how much movement I've actually got. What's created one problem is, of course, I've got a DRO on the milling machine as well now, and the scale for the X movement is along here, so obviously I've lost this bit, lost it a little bit more than necessary, obviously, because there's a cover over here, so I've lost quite a bit. I guess this is 1.5 inches I've lost here in travel. So using the pointer in the drill chuck, the travel I've got is from here, I'll put a little mark here to here. So basically I've got 3 1/8 inch travel, which is what about 80 millimeters across here. So that's the limiting factor. You see I've put drawn some lines on here at 30 degrees, so the workpiece has to sort of be mounted in here at 30 degrees so that I can machine across this way. Obviously it could be done the other way, I guess, and machine that way, but I don't know, it's going to make a huge difference really, but in reality. I mean, the ideal thing would be to use my rotary table vertically on here, but the rotary table with a chuck mounted in it, as you see, is absolutely huge. And if you put a chuck on here, of course it's going to overhang way beyond the movement I've got to machine anything. The rotary table, when I use it, it's mostly used flat onto the top here, and it means that I can machine things here within the range that I've got. I have used it before upright, but I've had to devise another means of mounting it, because the slots in the rotary table on each side are outside of the outside slots here. This would be fine if it was a much bigger milling machine, obviously. I could have bought a smaller one of these, but what I wanted was a rotary table that would take an adapter to use my Myford chuck on here. Another option was to use one of these square collet chucks. It's got to be mounted onto something because the locking nut here overhangs the base, so I thought, well, I could probably mount it on a 1, 2, 3 block, something like this, but mounting it right out here, there's really nothing really to clamp it onto to easily get the workpiece again within the range I have. So the answer I've come up with, whether this is a good idea or not I don't know, but is to use my fixture plate. with a V-block. Now I've set this up sort of roughly, basically just to show you. I've put some registration pins in here and one in the back so that I can push the V-block into place, and I can use some little clamps on this side to hold it down. Then if I remove this is a 30-degree setup angle, so I can remove that and then put some clamps on that side. The part then can be mounted in the top and held in place, hopefully with this. I'm hoping that this won't get in the way of the collet chuck. If it does, then I'll have to find a screw with a smaller head on it, which will clear. I'll have to just try that out first and see if it works. So that will be set there, and if this is set up like that, that will give me the 30-degree angle, so I can move the table in the Y direction and cut that part out. I guess it could be mounted the other way around, but I'm setting out this way because what I plan on doing, just going to tilt the camera up again, there we go. What I'm planning on doing is moving the rear fixed jaw plate to the back, and then I can wind the moving jaw right out. Did I move that out far enough yet? No. If I move that right out, sorry, it's taking me out to this by hand. Oh, the handle is there, but if I move that jaw there, then I can clamp that in there, and the area I need to cut is well within the range I've got across here. So that is, I think, going to be my solution. I just hope that I can set this up strong enough that the part won't move. I've got a couple of V-blocks, but this is the only one I've got that I've got a clamp for. I don't think this clamp I don't think this clamp was one that originally came with this. I picked this up at a model engineering show, and these two items were in different places on the table, and I took this over to the block there and discovered that did actually fit. So I've used this many times. It's out of the couple of V-blocks I've got, this is the one I've used most often. This one is a nice one. It's made by Eclipse. So I think that's going to be the solution. Just hope this works out okay, because it'd be a great shame to spoil this part right at the 11th hour, basically. But I'm hoping this is all going to work okay. What I'll do is very carefully set this up again on the bench, and then make lots of measurements and make sure everything lines up absolutely perfectly, which I hope it does. Now once I've got this set up, I mentioned earlier that when I face this end off, I put a tiny little dot in here, and I can use that as a data point. So I'll be machining out this corner, and what I'm going to do is set this up on, we'll set all of this up on my surface plate, and then I can use a height gauge, find that dot in the center, and then move the height gauge down the thickness of the carbide tip. So that will give me, because obviously the top of the tip has got to be in line with the center of this tool. I hope you sort of understand that. So that would do the job. With a much bigger milling machine, this would be so easy. I mentioned earlier on that one of the YouTube channels I've seen sort of someone making these was Randy Richards, but I went back and had another look at the video, and of course Randy makes these dovetail tools to sell them on his channel. Fair enough, you know, it's a bit of revenue to his channel. He makes them in a couple of different sizes, a small and large one. But what he's done, because he's making them in a sort of a mini production run, he's got a plate which goes on the top of the mill table with a machine groove in it, which I don't know what he's got. It's probably like a sort of a rotary table or something like that. Will lock into, so that he can keep going back to this same setup every time, and then lock the rotary table in position, so that the piece always ends up in the same position every time. But I'm only making one, and I'm never going to make another one. So there we are. So what I'll do is I'll get all this set up and bring you back for the cuts on this. I'm hoping this is going to work okay, and as long as I can clamp the block down firmly enough so that nothing will move. I can't put a strap clamp over the top of it, so luckily this has got a lot of grooves in here. The bottom grooves will be ideal to clamp it down. If I can clamp them down really firmly, then I'm hoping this won't twist while I'm machining it. But when I machine this, I'm going to take it very, very easily to machine it, so that hopefully nothing will move. I'll keep my fingers crossed there, but we'll bring you back for that part. Well, this is the setup I've got. See, I've mounted everything in onto the fixture plate here. I've put some strap clamps on, or finger clamps on this side, and clamped it down as tightly as I possibly can. And I've put the workpiece in the V groove here. I've put a little bit of paper under it, which might stop it from slipping. And I've clamped the screw down here as tightly as I can to hold it in position. So I'm hoping that this space here is enough for the collet chuck to revolve in while I cut across here. I did some other sort of setups to sort of check the angle here as well, just to hopefully ensure that this is going to cut at the absolute correct angle. And I mentioned that when I'd face this end off, I put a little pot mark in the centre here. The idea being that I could line up my height gauge with that centre point here, and then drop this down the thickness of the little carbide tip. But the carbide tip is 100 thousandths thick. So I don't know if you can see, I've got so I'd set that up. Took me ages to do this using various magnifiers and a torch behind, so that I could get the corner, or the other corner, actually that corner, lined up with that mark there. And you see I've set the height gauge here to minus 100 thousandths of an inch. And I've blued up the end of this. So what I need to do now is to scribe across the bottom, so that will be the depth that I need to machine down to. So if I scribe across there, that gives me a line to work to, which I hope you can see okay there. So the next job will be mounting this up in the vise on the milling machine, and then start machining this section out down to that line and across across here to a depth, so that when the carbide tip is mounted in there, there's a slight overhang on this side as well, so that the cutting tip is clear of the edge here. So there we are, that's the setup I've got, which I hope is going to work okay. Time will tell, really. So let's see how we get on. Well, I've got it all set up in the mill vise now, and as I mentioned, the faceplate of the fixture I've moved to the back of the vise to give me enough room to get the fixture plate in. So the fixture plate is resting on this surface at the back, and to make sure that it's lying completely square underneath here, up underneath, I've put one of my shop-made adjustable parallels to the same height as the jaw surface at the top, so that sits down nice and square, so everything should be absolutely fine. I set all this up, everything is clamped down as tightly as I can get it, and I've run the cutter backwards and forwards first to make sure I'm clearing this large knob on the top here, which clamps down onto the workpiece, and everything is fine. I'm using a 12mm 4 flute end mill. It's a very, very good quality one. I'm not even sure I've used this one before, and I've made a couple of little test cuts. So, earlier I showed that I'd marked a line here, which will be the total sort of depth of the cut that I need to make, and also put a line down here as well, which is as far as I need to cut in to allow the carbide tip to overhang this end just very, very slightly. So I'll run a couple of cuts across here, but the rest of it I'll do off camera, because I'm only going to make very, very light cuts at this, so that nothing moves at all. And I spent a lot of time trying to set this up as square as I possibly can, so I'm hoping at the end of the day this is going to work out fine. Okay, well that's just, you can see it's making quite nice cuts across here, and it doesn't look as though anything's moved. So that's as far as I'll take it on camera. But I'll bring you back when I've sort of reached the bottom, and then the final process will be positioning the carbide tip in here and marking the position for the hole and the tapped hole to be put down into here to hold the carbide tip in position. But I'll show you how I'm going to approach that a bit later on. This should be the last pass on cutting this part out here. Let's put a bit of lubricant in there, a nice clean cut, and I'm only using the best quality cat food for this job. It's really good for cutting. It is gourmet gold. Okay, I think that's fine. Yeah, it looks okay. We're on the line. Right, so that the next stage, I'll obviously do a little bit of a clean up round here, and the next stage will be putting the carbide tip in here and setting up to drill the hole so that I can tap it for the little retaining screw. Now the best way, I gather, to set this up for drilling is to use either a pin or a drill that's a nice tight fit into the hole in the tip itself. And I've gone through all the various drills I've got, and the nearest one is, I think, 2.7 millimeters. The screw that you use to hold these on is a 2.5 millimeter screw, so the tapping drill size for that is 2.1 millimeters. So once you use, I mean, I've not got a pin that's that diameter to fix this in place, so I spent a bit of time in lining this up so that I've got a bit of an overhang here and on the side as well. When the side is sort of basically set itself because of the distance across here, but then I've moved the wire movement just to give me an overhang here, so you've got a clearance under the bottom here and on the side, so I'm hoping that's going to be fine. I don't think it needs a huge amount of clearance for this, so I hope this works out okay. So the thing is, now I can move the drill up out the way and the tip, and then drill a hole. I'm going to drill the hole all the way through. I'm not going to drill it as a blind hole. I would much rather it goes all the way through, and I obviously clean up the other side of this. So if I raise the drill up out the way, and we can take the tip out and then remove this drill, and I'll put a drill in here to make a little center mark. Obviously you've got to be really careful doing this, because this is, I suppose, if any, the trickiest part of the job, really. So obviously we need that to guide the drill through. Now I get my tapping drill. Let's raise it up a bit, give me a bit more room. Put some cutting on that. Get some plenty of it. Okay. Something to like that. Oops, sorry. I'm knocking the camera here. Let's give that a bit of a clean up here. And I'll use the drill chuck to start the tap off, and then finish it with a smaller tap wrench. Get some, some cutting paste on that. Plenty of, give the tap every chance of going through okay. This is not going to be an easy operation by any means. Sorry if my hand gets in front of the camera, but obviously I've got to be careful at doing this. Let's just see whether that's I apologise that you can't see what I'm actually doing at the moment. I'm trying to ease the tap into the hole. See whether I've got a good, I think I've got a reasonable grip on that. I have a feeling that this tap wrench is not going to clear this here, so I just have to keep moving it round, I think. Well, the tap's coming through, so it seems to be working. It just takes a bit of time, doesn't it, to do this. I'm glad I've got these tiny little tap wrenches. They're so useful to get into very, very confined spaces. I think that's probably, well, I'm going to take it through, all the way through, make sure I get it hopefully a nice thread in here. Sorry this is taking so long, but this, if anything, this last step and breaking a tap off in this hole would ruin all the work and time I've put in so far. And I think that's okay. I'm just going to switch the camera off for a moment while I remove that, because that's going to take equally long to get this out as it did to get it in there. So bear with. Okay, well, that's tapped quite a decent hole in there, and I will put the tip on, although I've got to remove the tip when I take this out, and obviously deburr everything on here before the job's finished. But oops, if I can fit that in there without losing the little screw. There we go. Let's see if I use a little torque screwdriver to get that in. That's it. Put that in nice and tight. There we are. So that's it. Job done. I think I can quite safely remove that now, and I'm obviously going to go around all of this with a stone and clean it all up. Obviously clean the bottom under here, clean all the blue off, and then the job's basically finished. Let me just release the clamp on the top. I did put that in quite tight, and I put a piece of thin copper under here, so hopefully that I wouldn't mess up the the finish on here, and a little bit of a cigarette paper in there sort of helped as well to grip it. So there we are. I don't know whether there's enough light on that so you can see what it looks like. I've got my hand behind it. Is that in focus? Let's just, yep, I think we're in focus now. So there we are. I think it's turned out a lot better than I really expected it would. The proof of the pudding, of course, is will it actually work? That's the thing, though, isn't it? See if I can get this into focus again. Sorry about this. Oh dear. There we are. So that's it. It's my little dovetail cutter. Well, I hope you enjoyed this little series of making this. It's sort of something I really wanted to make for a long time. I've got a sort of a future project that I hopefully can use this for. But what I will do before then, I'll sort of run a test on it just to see if it works okay. Certainly looks quite nice, I think. Anyway, I think I'll call this an end to this little project now. Obviously, I'll let you know at some point in the future, if it worked really well. Perhaps film a little sequence of sort of cutting a dovetail with it as an experiment. Okay, well, thanks for joining me again in the workshop. Also very grateful to all the subscribers to the channel and the nice comments and everything else. So I'll see you soon with another video. Thanks very much indeed. Bye bye for now. Just a little bit of extra content if you're still watching. During the video I mentioned how I've mounted up everything onto my fixture plate, and then mounted the fixture plate into the larger of my milling vices. And I mentioned the way I fixed this in to make sure it was all nice and square and level. If I just release the jaw, you see what I've done is moved this fixture face from here to the outside, so that the fixture plate would rest onto here, but to make sure that it was lying perfectly level, I used my little jacking device here. I made this well, quite a few months back now. I did show a video on making this, so I basically adjusted this so that it's at absolute the same level as here, and then I can mount that against the moving jaw. Can you actually see that? Yeah, move it against the moving jaw here, and then when that's put in, that will rest on here firmly, and then that can be locked into place to hold it in perfect alignment. In the past I've done, not with the fixture plate, I have machined sort of larger pieces of material in here, but in the past the way I've done it is to put a parallel here and here to mount it onto, but I didn't think that was terribly satisfactory, and as I don't have a parallel exactly this height, but I mean that sort of worked. But I think this is a very good use for this little device, this sort of sliding parallel here. So I think that works really well. I just thought I'd show you that because I'm not sure when I explained what I'd done you couldn't actually see this, so I thought if you're interested, that's how I did it. Thank you.